Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Hello developers. In today's video, we're diving deep into Apache Polygene, a unique Java framework that challenges traditional object-oriented programming with composite oriented programming. We'll walk through its architecture, key features, and how it can transform the way you build modular, scalable applications. Apache Polygene is a Java framework that enables developers to build applications using composite-oriented programming. Instead of relying solely on classes and inheritance, Polygene uses composites made up of mixins, concerns, and side effects, leading to highly modular and reusable code. Traditional OOP can lead to rigid class hierarchies and tangled logic. Composite-oriented programming addresses this by allowing dynamic assembly of behaviors at runtime. This leads to cleaner, more testable code and better separation of concerns. At the heart of Polygene are mixins, concerns, and side effects. Mixins provide the core behavior, concerns handle cross-cutting logic like logging or security, and side effects track or react to method invocations, all assembled into a composite at runtime. In Polygene, composites are built from interfaces annotated with behavior-defining annotations. The framework handles dependency injection and aspect-oriented features transparently, allowing developers to focus on business logic. Polygene organizes functionality into modules, each encapsulating related composites and services. Units of work manage transactions across modules, ensuring consistency and enabling scalable, testable designs. Dependency injection in Polygene is transparent and declarative. You simply declare what you need, and the framework injects it at runtime. No boilerplate code, no manual wiring. It supports both constructor and method-level injection. Polygene integrates AOP natively using concerns and side effects. This eliminates the need for external AOP libraries and ensures cross-cutting logic like logging, security, or caching is cleanly separated from core business logic. Compared to traditional frameworks like Spring, Polygene offers more flexible behavior composition and less boilerplate. It's designed for modularity and testability from the ground up, making it ideal for complex, evolving systems. Imagine building an enterprise backend where each business domain, like billing, user management, or reporting, is encapsulated in its own module. Composites allow flexible behavior composition, making the system scalable and easy to maintain. Polygene naturally aligns with domain-driven design principles. Composites can represent bounded contexts, modules encapsulate aggregates, and mixins allow clean modeling of domain logic without infrastructure concerns. Polygene's modular design maps naturally to microservices. Each module can be deployed independently, and composites allow dynamic behavior composition, ideal for event-driven architectures and evolving service boundaries. Event sourcing is a natural fit for Polygene. Side effects can track state changes, composites model event handlers, and the framework integrates transparently with event stores, enabling robust, scalable event-driven systems. While Polygene introduces some runtime overhead due to dynamic assembly, it's optimized for efficiency. The transparent features like AOP and DI have minimal performance impact, making it suitable for large-scale systems. Getting started with Polygene is straightforward. Add the Maven dependencies, define your composites using annotated interfaces, and bootstrap the Polygene runtime. The framework handles the rest, from injection to AOP. Creating your first composite is simple. Define the behavior using interfaces, annotate them with @mixins and @concerns, and let Polygene assemble and instantiate the composite at runtime. No manual wiring required. Units of work in Polygene encapsulate transactions across modules. They support automatic rollback on errors and can be nested or run concurrently, providing robust transaction management without boilerplate. Polygene provides transparent entity management, supporting both JPA and custom persistent stores. It includes built-in query and indexing capabilities, making data access both powerful and easy to manage. The Query API in Polygene allows declarative query building with support for complex filters and joins. It integrates transparently with persistent stores, enabling powerful data retrieval with minimal code. Security in Polygene is handled via concerns, which enforce role-based access transparently. You can also implement custom security policies by extending the framework, keeping your system secure without cluttering business logic. Testing in Polygene is straightforward thanks to its modular design. Composites are highly testable, and the framework provides built-in utilities for marking and stubbing, ensuring your code is robust and reliable. While Polygene's ecosystem is smaller than Spring's, it includes IDE plugins, build tools integration, and solid documentation. The community is active and focused on enterprise-grade modularity and clean architecture. Compared to Spring, Polygene is more focused on modularity and composability. While Spring is mature and feature-rich, Polygene offers a cleaner separation of concerns and more flexible behavior composition, ideal for complex domains. The Polygene community is active and supportive. You'll find documentation, sample projects, and active discussions on mailing lists and GitHub. It's a great place to learn and contribute. Polygene has a steeper learning curve due to its unique approach. Start with simple composites, embrace modular thinking, and leverage the built-in AOP features to get the most out of the framework. Polygene is used in production for enterprise backends, high concurrency systems, and evolving architectures. Its modular design makes it ideal for systems that need to scale and adapt over time. The future of Polygene includes a continued focus on modularity, improved tooling, and better integration with cloud platforms. It remains a powerful choice for developers seeking clean, scalable architectures. To get the most from Polygene, design small, focused mixins, use concerns for cross-cutting logic, and structure modules around business domains. This ensures clean, maintainable, and scalable systems. While other composite-oriented programming frameworks exist in Net or Python, Polygene is the most mature Java native option. It offers deeper modularity and better integration with Java ecosystems. Polygene's modular design simplifies CI/CD pipelines. Modules can be tested and deployed independently, and the framework supports containerized deployments, making it DevOps friendly. Debugging in Polygene is aided by its transparent behavior model. Built-in profiling tools and support for standard Java debuggers make it easy to identify performance bottlenecks and logic issues. Migrating to Polygene can start with new modules, gradually refactoring existing code. Adapters can bridge legacy systems, allowing a smooth transition without disrupting current operations. Polygene naturally supports common design patterns. Concerns implement the decorator pattern, side effects enable observer patterns, and composite assembly acts as a factory, all without extra boilerplate. Polygene integrates well with reactive programming. Side effects enable reactive flows, and the framework supports transparent asynchronous execution, making it a strong fit for reactive systems. In cloud-native architectures, Polygene modules can be deployed as microservices. The framework supports transparent scaling and resilience, and integrates well with Kubernetes and Docker. While powerful, Polygene can be misused. Avoid over-engineering with too many mixins, ignoring modularity principles, or mixing concerns directly into mixins. These can lead to complexity and reduced maintainability. Apache Polygene is a powerful tool for building modular, scalable systems, especially in domain-driven environments. Start experimenting with small composites today and see how it transforms your architecture. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.